Hello friends, there's a lot going on in this question, number 15 from the summer homework, so hold on tight, lots of stoichiometry. Make sure that you have your calculator super close by. So, question reads aluminum and iron 3 oxide react to form iron and aluminum oxide. The first thing we're going to have to do is turn these words into a balanced equation because we need the coefficients from the equation to make our mole ratios to do all the stoichiometry that we're about to do. Aluminum and iron 3 oxide. That Roman numeral 3 tells us that that transition metal iron has a charge in oxidation state of +3. Oxygen here is going to have a charge of -2. To balance out those charges, I need a 2 and a 3 because 3 times 2 is 6 and 2 times 3 is also 6. The formula for iron 3 oxide is Fe2O3. We're going to form iron, that's Fe by itself, and aluminum oxide. Again, we need to balance some charges. Aluminum here is going to be a +3. Oxygen is still a -2. So once again, 2 and 3 to balance out those charges. The formula for aluminum oxide is Al2O3. Let's balance this equation. I have 2 irons, I need 2 irons. I have 2 aluminums, I need 2 aluminums. We have 3 oxygens on both sides. Balanced equation accomplished. Next up, let's think about the rest of the words. What mass of iron is produced from the reaction between? I have 2 masses for my 2 reactants. I need to figure out actually what the limiting reactant is in order to find the answer to this question. So what we're going to do is turn the masses of my reactants into the mass of this product. The reactant that makes the lesser amount of product is the limiting reactant, and it will also be the possible mass of product produced. Let's do it. So first up, 21.4 grams of aluminum. We're going to turn the mass of aluminum into the mass of iron. To do that, I need to turn my grams of aluminum into moles of aluminum. Aluminum's mass is 26.98 grams per mole. So we have successfully canceled out our grams. I have moles of aluminum. Let's turn those moles of aluminum into moles of iron. We're going to do that with our mole ratio. Aluminum on the bottom, iron on the top. 2 in front of aluminum, 2 in front of iron. We now have successfully canceled out aluminum. I have moles of iron. I don't want moles of iron, I want the mass of iron. And so we're going to extend our railroad tracks just a little bit more. Moles on the bottom, grams on the top. The molar mass of iron is 55.85 grams per mole. We have now successfully canceled out moles, and I'm left with grams of iron, which is super cool because eventually I want to know the mass of iron. So with my calculator, we're going to do 21.4 times 1 divided by 26.98. I'm not going to worry about my 2's because 2 and 2 cancel each other out. I do need to multiply that by that 55.85. And so our answer is 44.299, lots of digits, grams of iron. I'm not going to worry about sig figs yet. I'm going to do all my calculations and then come back and check. So this is the grams of iron possible produced if all the aluminum reacts. But I don't know yet if all the aluminum is going to react because I don't yet know what the limiting reactant is. So we're going to do all of this all over again with the mass of the other reactant, the iron 3 oxide. So more railroad tracks, 91.3 grams of that iron 3 oxide. We're going to pretty much do the same exact process, but with iron 3 oxide instead of aluminum. So step 1, get rid of those grams, turn those grams into moles. This one's a little bit trickier. It's a compound. I need to add up some stuff. So I need 2 irons, 55.85 times 2. Add 3 oxygens at 16.00 a pop. And that's going to give us a molar mass of 159.7 grams per mole of iron 3 oxide. We have successfully gotten rid of those grams. Next up, we're going to turn our moles of iron 3 oxide into moles of just iron. Use our mole ratio, Fe2O3 on the bottom, just that iron on the top. 2 in front of iron, invisible 1 in front of iron 3 oxide. We have now successfully canceled out that iron 3 oxide. We are left with moles of iron. Let's go back to grams. Moles on the bottom, grams on the top. The molar mass of iron is still 55.85 grams per mole. We have successfully canceled out the moles. Let's find our calculator. 91.3 divided by 159.7 times 2 divided by 1 times 55.85, and our grand total is 63.858, lots of digits, grams of iron. So now we're going to think, could I make 44 or could I make 63? We can't actually make 63 whole grams of iron because I'm going to run out of aluminum, because I can only make 44 grams from the aluminum. That means that our limiting reactant is aluminum. Aluminum is limiting because it made the lesser amount of product. I can't make as much iron with my aluminum as my iron 3 oxide, hence aluminum is limiting. So now we're going to go ahead and come back and check sig figs here. I get to keep 1, 2, 3, 1, 2, 3. That 9 is going to turn that 2 into a 3. And so my final answer for what mass of iron is produced, 44.3 grams of iron can be produced. And then my excess is going to be not the aluminum, but the iron 3 oxide, because it can make more iron. And so final piece of the question, Fe2O3 is in excess. Good? Good.